When we talk about an arc length of a circle, what are we referring to? Where would that be located on the circle? At the outside. Okay. So if we are talking about arc length, and we want to find what the arc length of something is, this would be an example of arc length. That would be our arc length if we wanted to know the arc length between those two particular values. Arc length is always associated with some sort of central angle. So there would be my central angle, and it's associated with that arc length. And we can find it by just using a simple proportion. So when we deal with a circle, your angle measure here is a certain proportion of your circle. How many total degrees are in a circle? 360. So if our angle measurement is in degrees, we have a certain part of it, whatever that angle is over 360. That angle measure is corresponding with this arc length. Okay? The angle measure is corresponding with the arc length, and then what would the total distance around the circle end up being? What's that represented by? What's that called, the distance around the circle? Yeah, the circumference. So it would be the arc length over the circumference. Okay, but what's the formula for circumference? 2 pi r. So we could say, instead of c there, we could say 2 pi r. So and if you have the central angle and if you have the radius, you could certainly solve for the arc length. Arc length. L is arc length. So we're going to find the exact length of the arc with a radius of 5 centimeters, and it has a central angle of 210 degrees. So where would I put the 210 for your angle? So 210 over 360 would equal your arc length, which we're trying to find, over your circumference, which is 2 pi r. Well, what does it say the radius is? 5. So 2 pi times 5. Well, what is 2 pi times 5? Yeah, 10 pi. So we could just write that as 10 pi. So instead of 2 pi times 5, that is 10 pi. Now, if we want to leave this exact, that means we have a pi in our answer. So how do we get the arc length alone? Multiply by what? Yeah, multiply by your 10 pi. So those cancel. So now you have 210 over 360, which you can just simplify down using your fraction button if you want to. And then you'd have to times it by 10, because we want it exact, and you're going to write it as an improper. So what would that be as an improper? 10 times 210 over 360. Okay, but let's simplify it down. Yeah, you can simplify that. Yeah, simplify it down. Okay, and so as an improper fraction, what would this be? 35/6. So 10 times 21/30 is 35/6. We still have the pi though, so where would that go? At the top. So we have 36 pi over 6 centimeters would be your exact length. Okay. How would you find this approximate to the nearest hundredth? How would you find this to the nearest hundredth? Yeah, just times it by the pi. Not that hard, just times it by pi. So in your calculator, take it and times it by pi. What do you have to the nearest hundredth then?
So 35/6 times pi.
Right, that's what it says up there, 35 6 pi. So just put it in your calculator. What do you end up getting? 0.3 what? 3 centimeters. So there we are, exact and to the nearest hundredth. Okay? You did that in geometry. You didn't stop and leave it exact, but you did that in geometry. You found arc lengths. So now let's do it with radians. So what changes when we deal with radians? Will we still be over 360? No, what will we be over? We'll be over 2 pi instead of 360. Is equal to arc length over 2 pi r. That won't change. But now for radians, what do you notice now about your two denominators? They both have pi's in, and they both have what? 2 in. So could we simplify this down even further? How could we simplify this formula down further? How can we get rid of them? Okay, we can multiply both sides by 2 pi. So if we multiply both sides by 2 pi's, what happens to the 2 pi's? They cancel. So now we have the angle measure is equal to the arc length over the radius. So this only works if we have radians. Our other formula works for degrees. So what is the central angle of radians equal to? What proportion? Describe that to me in words, what L over R is. What does L stand for? What length? The arc length. What does R stand for? The radius. So how does your central angle in radians, what is that equal to? Yeah, the arc length over the radius. So that's a proportion. So the radian measurement for your central angle is arc length over radius. It's really a pretty cool proportion that you can get with radians. So how are we going to set this up so we can find the exact length and to the nearest hundredth? We have a radius of 7 meters and a central angle of pi over 6. Yeah, pi over 6 would be our angle, so pi over 6 is equal to arc length over 7. How would you solve for arc length? Times by 7. So exact, how are we going to write that? Yep, 7 pi over 6 meters would be exact. How do we get that to the nearest hundredth? Yeah, just take 7/6 times pi, and what do we get to the nearest hundredth? Yep. Okay, does that make sense? Okay, so let's look at your unit circle a little bit more here. What if you guys all have filled in now after your worksheet yesterday? So I think we had 0 here and 360 here and 2 pi, right, and 0. What was our first angle? 30 degrees, and what's it in radians? Pi over 6. Okay, what did we get for our next angle? 45, and what did you find out 45 was in radians? Pi over 4, yeah. What's our next angle that you got? 60, and what's 60 degrees in radians? Yeah, pi over 3. Okay, going straight up. 90, what's 90 degrees in radians? Yeah, pi over 2. Did you have to find that one out, or did you just figure it out? You just figured it out. So let's think about it. This is 0 over here. What's our radian measure to the left? Pi. Okay. 180 degrees or pi. Well, between 0 and pi, 90 degrees is halfway, right?
Yeah.
So if you're between 0 and pi, that would have to be half a pi, or pi over 2. What's the next measurement you got? 120 degrees. What? 2 kind of dropped down low. And what radian measurement did you get? Yeah, 2 pi over 3. So next one you got? 135 degrees. 3 pi over 4, yep. Next one down? 150 degrees. 5 pi over 6. And then we have 180 in pi. Okay, so let's try to figure out the bottom half of this. Okay, so we have this pattern. All right, we go up 30 degrees, and then it's an increase of 15, an increase of 15, and 30 again. 30 degrees, increase of 15, increase of 15, 30. So this next angle have to be in degrees. 210, yep. What would our next angle have to be in degrees? Yep, 225 degrees. What would the next one have to be in degrees? 240 degrees. Straight down, I think we did do this one as well. 270. Okay, and the fourth quadrant, what would our next angle measurement be? 300, yep. And then what? 315. And then 330. Okay, so that's degrees. Now we want to think about radians. So to think about radians, we're going to take a look at these fractions and see if we can come up with any patterns. So right here, let's just focus on the 30-degree increments. Okay, so we're going to ignore the 45, the 135, the 225. So we start at 30 degrees at pi over 6. Our next one is pi over 3. But if I write this as a fraction over 6, it's 2 pi over 6, right? You guys agree with that? Okay. Our next 30-degree increment here is pi over 2. But what if I write that one as a fraction over 6? What do we have?
3 pi over 6.
Yeah, 3 pi over 6. Okay, what do you notice about these fractions of pi over 6? 1 pi over 6, 2 pi over 6, 3 pi over 6. So they're going up by 1. Does that make sense? We're increasing by 30 degrees each time, so we're taking one additional chunk each time. Okay, so if this is one piece of our circle, now we have 2 of them, now we have 3 of them. So 120 here, we have written as 2 pi over 3. How would you write that as over 6? 2 pi over 3, how would you write that as over 6? Yeah, 4 pi over 6. Okay, what's our next one that goes by 30? The 150? That one says 5 pi over 6. Does that still follow the pattern? 1, 2, 3, 4, 5. What would you anticipate 180 to be written? 6 over 6, which is pi. Okay, and we can actually just continue this pattern with the 30 degrees. Because this is just a circle split into even increments. Okay? It's like the very basics. When you guys first learned about fractions, you typically one of the first problems you did is you had a circle. You normally called it a pie or a pizza. And you would have things like this. And you'd have one of them shaded in. And you would say this is 1 out of 1, 2, 3, 4, 5. Right? I mean, that's one of the first things that you ended up learning about. If you had 2 of them shaded, you would then say, oh, you've got 2 out of 6 here. Okay? This is that same idea. So if we go to 210 degrees, what should the radians be? If this is pi, which we know is 6 pi over 6, and every 30 degrees we're increasing by 1, what would 210 degrees be? 7 pi over 6. Okay, the next time when we increase by 30 degrees, we're at 240. So what would be the next increase here? Before reducing it, what is it? Okay, so it's 8 pi over 6, but that can be reduced. What can 8 pi over 6 be reduced down to? 4/3. So this would be 4 pi over 3. Okay, what would 270 be? Okay, 9 pi over 6, but that can be reduced to what? 3 halves, so 3 pi over 2. Okay, what's our next measurement on here? 270, then we go to 300, which would be what? So before you reduce it, 10 pi over 6, and reduce down is 5 pi over 3. And then 330, what would that be? 11 pi over 3. Over 3? Over 6. 11 pi over 6. Okay, so those are all of our measurements when we increase by 30 degrees. Could we do something similar when we increase by 45? Probably. Because if every time we increase by 45, that also is going to increase by the same amount. Okay, so we're going to take a look at that, increasing by 45. And do the same type of idea. Oh, I erased my 90. Okay, so at 45 degrees, we're at pi over 4. Okay, where's our next increase when we increase by 45 degrees?
90.
That's at 90. So 90 is currently says pi over 2. How would we write that as a over 4 though? 2 pi over 4. Okay, so here's our first piece at pi over 4. Our second piece would be 2 pi over 4. Third piece at 135 says 3 pi over 4. So then 180 would be our fourth piece, and it would have to say what? 4 pi over 4, which reduces down to pi. So now if we go another 45 degrees, where do we end up at 225. So what would that have to be?
5 pi.
Yeah, 5 pi over 4. Okay. If we go another 45 degrees, where do we end up being? Not quite at 315. We have to stop at 270 first. So if this is 5 pi over 4, what is 270? 6 pi over 4. Does that simplify down to 3 halves pi too?
Yeah.
Yeah, okay. So then where would 315 have to be? 7 pi over 4. Okay, so there on our unit circle, now you should have all of these angles written out. Okay, so you should have all the angles in with all the radians. And then tomorrow we're going to use this even more and add some more stuff to it. Okay? Because this unit circle is nowhere near done. It's got a lot more information for us.